Good morning, everyone. I'll be kicking off our session today on create your own plugins for OpenSearch. A bit about us. Hi, I am Nishtha. I am SD2 working at AWS OpenSearch. I have along with me Craig, who is Senior Software Engineer, and Gaurav Gupta, who is SD1 in AWS OpenSearch Security Team. Before we jump in, let's quickly look at what all we'll cover today. So we'll start with a brief intro to OpenSearch, and we'll discuss why do we need plugins. We'll cover the different type of plugins available and when is the right decision to build one. We'll take a quick look at high-level overview of the plugin architecture. After that, Craig will take over to show you exactly how action and extensible plugins work. These two are the major type of plugin categories. And finally, we will cap it off with hands-on session from Gaurav, where you will build your very first plugin and use it with OpenSearch. Let's start with a quick look at OpenSearch itself. OpenSearch is your all-in-one platform for search and analytics built on Apache Lucene. It delivers lightning-fast, relevant search results at massive scale. It provides smart analytics and observability across logs, metrics, and data. OpenSearch is built to be secure by design, so it has enterprise-grade security features. It scales effortlessly from startups to massive clusters. And most importantly for us today, OpenSearch is an extensible platform, which means you can extend it using plugins to meet your specific needs. But why do we need plugins? Think of a moment when you would have said, I wish OpenSearch could do this. Plugins make that wish a reality. They let you extend and enhance the core OpenSearch functionality from custom analyzers and some specialized algorithms. They let you solve and adapt to your unique challenges, like integrating with some internal tools or building your custom dashboards for the industry. They let you build and choose, which means you can either build a plugin from the scratch, leverage existing community plugins, or combine both for the perfect solution. So the benefits are clear. Plugins are modular, reusable across clusters, and flexible, allowing you to add only what you need. Plugins let you innovate safely, which means you will never have to need to modify the OpenSearch core code to use plugins. Now, let's look at the type of plugins available in OpenSearch. The OpenSearch plugin system is incredibly rich. It allows you to tailor every layer of search experience with the right plugin. As you can see, there's plugin available for almost any task. You want custom text processing? That's an analysis plugin. You need new ways to search or rank results? That's a search plugin. You want to add a new API endpoint? That's an action plugin, which Craig will dive deep into later. You want to transform your data, like masking personal identifiable information? That's an ingest plugin. There are script plugins available to add custom logic and even for more advanced tasks. These tables give you an idea of the scope and some simple examples. Now, with all this power, it's tempting to build a plugin for almost everything. But before you start building, ask yourself, do you really need one? So it's perfect to build plugins when you need some domain-specific text processing. For example, custom analyzers for legal documents or maybe some biomedical terms. It's perfect when you are implementing custom ranking or scoring logic for a vector search algorithm. It is ideal for external system integration and specialized data pipeline. However, if your need can be met with the existing configuration, some scripts or some mapping, or if it is just a one-off requirement, the plugin might not be the right choice. The goal should be to extend OpenSearch powerfully while keeping your stack clean and maintainable. Plugin gives us great power, but with great power comes great responsibility. So now let's discuss on what all things we need to keep in mind while building plugins. Plugins can cause some cluster stability and performance risk as they run inside the same OpenSearch JVM. So buggy or inefficient code can crash codes, can consume your JVM or CPU or memory, and basically it can degrade the entire cluster performance. To avoid, you need to load test the plugin in a full-scale replica environment and monitor metrics like heap view, garbage collection, indexing throughput, latency, etc. Plugins run with the same core privileges inside the cluster. So there are some security risks associated as well. A vulnerability in the plugin can lead to data theft and service outage. To prevent this, apply the least privilege principle, which means only request resources and permissions, bare minimum resources and permissions for the plugin. Plugins are tightly coupled to an OpenSearch version, so there are operational risks as well, as they can block crucial upgrades if plugins are broken or abandoned. To Prevent this, maintain a compatibility matrix, and build and test your plugin for each targeted version. Plugins can cause some functional risk as they can cause conflicts, break existing functionality, or can return incorrect results as well. So you need to have a proper structured logging and expose health and performance metrics as well from the plugin. Before we start building, let's do a quick architecture overview. The foundation is simple. Every plugin extends a single base class. From there, you can extend the functionality by implementing interfaces like ingest plugin, analysis plugin, script plugin, depending on what you want to build. The lifecycle of plugin is managed by OpenSearch itself. So the plugin gets discovered and loaded when the node starts. During the process, it registers its extension points, which means settings, module handlers, for example, new REST API endpoints, and then expose these points as services within the cluster itself. As now we know about the plugin landscape and architecture, let's see how to install a plugin with the OpenSearch. As you can see, this is how the plugin project structure should look like. So there are two critical files in every plugin. The first one is plugin descriptor.properties. It tells OpenSearch about the plugin, like the plugin name, plugin description, plugin class, and most importantly, the compatible OpenSearch version. This file should be at the root of the project. Secondly, plugin security.policy. This is an optional file which defines the Java security manager permissions for the plugin. You can use the OpenSearch Gradle or Maven plugin to assemble everything into the zip file, and that's what we will install on the cluster. Then you need to copy the plugin zip and run install command from the OpenSearch home directory. This will place the plugin in the correct directory for the startup. Then start the OpenSearch process, which will automatically load the plugin. And after that, you can verify the installation using Node's plugin API or Cat's plugin API. With this, I'll hand it over to Craig to explain you in detail about action and extensible plugins and showing you how exactly they work.
All right, thank you very much, Nishtha. So it's important to know that on one of the previous slides, you saw a lot of the extension points from the core. One thing I did want to note is that isn't a static list. People extend the core in new ways all the time. And if you go into the org.opensearch.plugins directory, you'll see the full list of extension points from the core and ways that you can extend core functionality. I also wanted to mention this talk is OpenSearch plugin focused, but all the major components in the OpenSearch ecosystem are extensible. So you can create dashboards plugins as well or data prepper plugins as well. So as Nishtha mentioned, in order to create a plugin, you need to extend the plugin base class. So here on the screen, I showed a little snippet and wanted to highlight two very important methods here in the plugin class that you may override. One of those is the create components. And so OpenSearch uses dependency injection using that @inject annotation, if you've ever seen that in the OpenSearch code base, to hydrate some of the components with their dependencies. And this is particularly useful in transport actions. And as we show you how to create a REST API, this will particularly come into the picture there. And then the other one to highlight is this get settings. So if you have cluster settings defined from your plugin, you would define them in this get settings method and return the list of your settings. And so on the screen there, you'll see an example of just like an integer setting. In this case, this is one coming from the security plugin. So your setting name, you might want to identify the plugin as well so that somebody configuring it knows which plugin has defined the setting. In this particular case, it's an integer setting, so you can also specify a default value, some setting validation. Since it's an integer setting, we can set a min value to prevent it from being a negative number, and then a list of properties as well. In this case, you'll see this node scoped and dynamic. Dynamic means it's changeable at runtimes using the put cluster settings API. There's some other ones like filtered if you don't want it returns on the list of settings when calling get settings API. But when defining your setting, you provide those list of properties there. And now some settings could be considered secret values, for instance, passwords, things like that. You might not want to include them in your OpenSearch.yaml file. OpenSearch does have a notion of secure settings, which uses the OpenSearch key store, which has the data encrypted there, but can be read by the OpenSearch process. And so you don't need to store those necessarily within the OpenSearch.yaml file. As Nishtha mentioned, I wanted to cover two, what I consider major plugin categories here. In this particular case, we're going to go deeper into action plugins and extensible plugins. And the reason action plugins I really want to highlight is because this is how you can define new REST APIs in OpenSearch. And in these, you would define a REST handler, and then usually you can define transport actions as well. And so these are typically coupled with a dashboards plugin. So if you have a dashboards plugin, you most likely have a corresponding backend plugin as well that defines an API. And then extensible plugins actually lets you define extension points outside of the core code base. So you don't necessarily even need your extension point to live in the core code base. And you can define relationships between plugins. And we'll go a little bit deeper in that in just a moment. But the quintessential example of this is the job scheduler plugin. So if other plugins want job scheduling capabilities, they might extend the job scheduler, which the extension point is defined in the job scheduler plugin and not the main OpenSearch repository. So this is what one of the extension points of the core looks like. This is action plugin here, just some of the key methods. And so this is an interface, and you'll see how you'll find these usages in the OpenSearch repo if you want to take a deep dive. But on this particular interface, I want to point out 3 important methods that you'd override for your action plugin. The first is get actions to define new transport actions, get action filters to run filters before transport actions execute on a node, and then get rest handlers. So I want to start from the bottom to the top. Get rest handlers is where you'll actually provide the list of rest handlers. Those rest handlers is where you're going to define your routes and how to handle the routes. Get actions would be where you define different transport actions. And transport actions, the node that receives a request necessarily might need to go to other nodes of the cluster to fulfill the requests. Like for instance, for a search, the node that receives the request might not have shards of your index, so you need to go to different nodes of the cluster that have shards for the index being searched upon. Or for instance, with cluster health, if a data node receives the request, it might need to go to the cluster manager to get the actual health of the cluster. And so you use the transport layer to do the internodal calls there. We can go into that in a little bit more detail. The other one I really wanted to point out was get action filter, and I might be biased as a security plugin maintainer, but these are used quite thoroughly as well on other plugins. These are filters that get applied before transport action. So at least speaking from the security plugin point of view, this is how authorization takes place. So this is a gate that says, do you have permission to perform the action or not? If you do not, exit early, don't execute. If you are permitted, then proceed to execute the transport action on that particular node. So here's an example of a REST handler. Now, the code snippet you see on the screen is actually the main REST handler of OpenSearch. So if you ever call the root, like port 9200/, this is actually the code for that REST handler. So there's 2 things to point out here, the routes. This is where you're going to define the HTTP verb and the path. So in this case, / because it's the root route. And then a REST channel consumer. So REST channel consumer, you can reply directly to the client, but more often than not, you're actually going to go to transport from here. One thing before talking about transport in particular, you could also consume parameters here. So you'll see one parameter in there, pretty. If you want to prettify the response, instead of returning the JSON on a single line, you can pass $pretty at the end of the URL so that it's prettified JSON in the response. Just one thing to point out here, in order to go from REST to transport, you use the node client, which is passed through this handler, through the, you see it extends the base REST handler. That client.execute main action actually executes the main transport action. And now let's go into that in a little bit more detail here. So the code you see on the screen now is actually the code for that main transport action. And as talked about earlier, dependency injection, you'll see the constructor there is annotated with that inject. You never directly construct this. It just exists there, and all of the dependencies are injected into that constructor. Anything you return from create components is injectable into these. There are some pitfalls to know when writing transport actions, particularly around backward compatibility. And when we talk a little bit further about testing, it's important to have tests in this area to test in mixed cluster scenarios, particularly if you want high availability. The other thing I really wanted to point out is, OpenSearch is a highly performant system. You never want to make a blocking action. And so you'll see in the code base this action listener. It's very similar to a JavaScript promise. You have to override the onResponse or onFailure methods. Depending on the outcome of the request, if it was successful, it'll go to onResponse. If it failed, it'll go to onFailure, and you have to handle both cases gracefully. But you never want to block the transport thread. If you ever try to do a blocking action, you'll get an error message. So that's it for action plugins. That was how you define a new REST API. In that particular case, the root API of OpenSearch. Another plugin category I want to dive in on is extensible plugins. So you can actually write your own extension points, but in a plugin itself. So what you see on the screen is actually another extension point, in this case, the one provided from the job scheduler. And so with extensible plugins, you can define relationships between two plugins. So you'd have the extensible plugin and the extending plugin. And important to point out on this screen for the job schedulers, you'll see in there, you'll see methods like getJobIndex and getJobRunner. Job scheduler listens into index operations on the job index to find changes in schedule, or if a new job exists, or if a job is disabled, and it can react accordingly. So it needs to know where the metadata for the jobs is stored. So if you extend the job scheduler, you need to define where you're going to persist that job metadata. The job runner would be how job scheduler itself then connects to other plugins, because when a job is due to be run, it will trigger the job runner of the plugin that extends the job scheduler. Say if I'm the reporting plugin and want to run reports on a schedule, I'll have a reporting job runner that job scheduler triggers and then delegates to the reporting plugin. There's a couple things to be conscious of when you're developing an extensible or an extending plugin as well. What you see there in the snippet is a snippet from a build.gradle file of the reporting plugin and how you declare a relationship to the job scheduler plugin. So you would say extended plugins, OpenSearch job scheduler. Now that interface that you saw on the previous screen there would not be in the main job scheduler repository. It'd actually be in a separate library called the service provider interface. It might be in the job scheduler repository, but you won't find it in the zip file of the plugin when you assemble it. And so you need to publish this SPY library that contains the interface of your extension point, and then extending plugins will then define a compile-only relationship on that library. Why is it compile-only? Well, it's because when you have an extensible and extending plugin relationship, the extensible plugin is required to be installed in order to install your plugin. So if reporting depends on the job scheduler, you must have that installed before a reporting plugin gets installed. And because of how class loading works, that interface would be available at runtime. And then the last thing to note here is if you do extend that job scheduler extension, you need to create a file in meta-inf services of the extending plugin, where you define which class in your plugin extends that interface. So in this case, the name of the file would be the org.opensearch.jobscheduler.spy.jobscheduler extension, and then the contents would be the class that implements that within the reporting plugin. Now, one other category I want to talk about, and this is actually a subcategory of action plugin, but it's called system index plugin. So if you need persistence, you would use a system index. So system index is where the system can store metadata in order for it to operate. So, two examples of this might be the security index, where the security posture is stored, or, the open distro ISM config, where your ISM policies may be persisted within the cluster. So one thing I just wanted to point out here is system indices have special protections in place because they are used by the system. Regular users cannot write to these, they cannot delete them, but plugins do need access to them. And so you'll see that the pattern here is on the screen here, you would stash the thread context and then access the system index. So this is an example from the job scheduler where it's going to acquire a lock, which is an index operation into a system index. So you'll see within the block there, it's using the node client to perform an index request. One other thing that I know I've been in a lot of conversations recently on too is whether you should put your plugin in the core repository, because there are plugins that live in the core repository, or if you should have a separate repository, whether it's under the OpenSearch project organization or your own repository itself too. Well, one thing that does get brought up here is, if you have your own plugin repo, you can define your own set of maintainers, your own tests. You don't have to have the whole Gradle check of the core repo running when you have your own separate plugin repository. If you're creating your own plugin repository, we actually have a template you can use as well. And so I put a link there on the screen to that template repository. You can see you can create a new repository from the template, which will help give you a lot of the scaffolding for creating your own plugin. There's also actually an OpenSearch plugins repository as well that has more information, a lot of which is covered in this talk as well, about conventions used across plugins, testing or otherwise. So now I did want to touch briefly on testing, like how do plugins test adequately? Well, we have this framework provided by OpenSearch Core called test clusters, where you can actually test within memory nodes. So you can write integration tests that realistically spin up a cluster, install a plugin, and then you can write REST requests against that. And then you can even do this with multiple nodes. They're all in the same JVM. So, there are common pitfalls you should know as plugin developers, particularly when you run, in multi-node environments. Don't always run in a single node environment. So run with tests in many different configurations. Backward compatibility, test in mixed cluster scenarios, rolling restart scenarios, especially if you need high availability. If you could do a full cluster reboot and can deal with downtime, then backward compatibility might not be as big of a concern, but if you have high availability and want to do a rolling restart, it's important to have tests to catch issues. And using test clusters, we were talking about extensible plugins. You can actually install those in test clusters too, so you can test with all of the dependencies that you need. And a snippet here, this is from the index state management plugin, which does have a dependency on job scheduler, and you can see when it's setting up integ tests that it gets installed. So BWC, shorthand for backward compatibility. There's a couple different scenarios you want to test: full cluster reboot, mixed cluster test, rolling restarts. Maybe start with 3 nodes, kill 1, bring up the new node, kill the second, bring up the new node, kill the third, and then perform the full upgrade. With backward compatibility tests, there's always going to be a from version and a to version. You might just test like a minor version upgrade, 2.18 to 2.19, or you could test from the previous major version to the next major version. Now, we do fully support rolling restarts from the last minor version of the previous major to any version of the current major. So it is important to test there. There are some major pitfalls to be concerned with, particularly around serialization and deserialization, like internodal communication. Whenever you see methods that accept stream output or stream input, these are the methods that are used for wire format for transport requests. And so if you ever add to an object and the serialization changes, if you're in a mixed cluster scenario, you can get into scenarios where 2 nodes might be talking a different format. So you need to identify by using version guards and serialize and deserialize what the other node would expect. And with that, I'm going to hand it over to Gaurav to demonstrate building your own plugin.
Hey, thanks, Craig, for that really insightful session. So now we'll go through an example on how you can create your own very first plugin. So firstly, we'll need to figure out what problem are we solving, like what type of plugin interface do we need for our application. So here in our case, we wanted to mask the response at the time of document ingestion. So I'm using an ingest plugin here. You can go ahead, clone the repo. You have the QR code right here. So I'll briefly cover what the PIM masking plugin is. So it's basically like a classic example of an ingest plugin, which helps users to mask their personally identifiable information. I like to call it PI, so bear with me, during the indexing process. The objective here is to ensure that your sensitive data never gets stored in an unmasked format in your storage, and which might save your business someday from compliance issues. So yeah, and so for example, you can see here the input says user some email with some SSN, and but we don't want to ingest it in our storage, so we'll use this plugin, and this will convert it into some masked format, like as you can see in the output. I'll briefly cover all the core components which this plugin has. It starts with the PI masking plugin class. It's the main plugin entry point. Then we have the PI masking processor. It's more or less like an orchestrator for our plugin. Then we have the PI detector. This is where our main masking logic resides. And then we have the PI detector. The audit logger. This mostly for compliance purposes. It's just logging and stuff. Then we have the PI configuration.java, which handles all the configurations. We'll discuss each of these components in the upcoming slides. So yeah, firstly we have the masking plugin class. This is the main plugin entry point. It basically registers all the Pi masking processor with the OpenSearch plugin system. As you can see, it extends the plugin class, and it implements an ingest plugin, which basically it's what we need. So it implements the ingest plugin interface to provide all the processor factories which we need for our plugin. It basically acts like a bridge between your custom code and the OpenSearch core process. This class basically ensures that our plugin is discoverable by OpenSearch when the process boots up. Next up, we have the Pi masking processor class. This is like heart of our system. So this is where all the documents gets processed and the Pi gets masked before storage. So it basically intercepts all the documents during the ingest pipeline. It scans for the configured fields. In this case, we will be masking message, user email, and the details field. It enforces strict mode policies and coordinates with the audit logging. It updates all the documents which we need with the mask content before indexing. It mostly serves like an orchestration layer that manages the complete Pi detection and the masking logic with the OpenSearch ingest pipeline framework. Next up, let's look at the Pi detector class. So it's our smart pattern recognition system. So here, for example, I've used the regex pattern for Pi detection, but you can be as creative as you want. You can use machine learning algorithms to detect Pi as per your convenience. So it supports various fields like email, SSN, credit card, or any other field which you don't want to share with the public, like you don't want it to store it in an unmasked format. So what it does, so when it detects the Pi, it then replaces it with some configured mask. We'll configure it in the Pi configuration. It then, as a response, it returns the detailed metadata about what was found and what was masked. Next up, we have the audit logger. So this is where all the compliance and tracking issues are solved. In simple terms, it's just basic logging mechanism. So it creates a structured log, as you can see. So for every operation, it logs all the plugin operation with timestamps and document correlation. It does store the masked values and the original values for like complete transparency. This class will basically help you to meet all your compliance requirements like the GDPR and HIPAA. So it's basically it's essential when we are dealing with such sensitive information in our case. Next up, we have the Pi configuration class. This is like our control center. This manages all the rules and settings for Pi detection logic. It defines like what all Pi patterns to detect and how do we mask them. We can specify all the fields which we want to scan. In my case, I have taken message, user.email, and details field. I'll show you that in the live demo. It manages the enable and disable state and also regulates the strict mode settings. So before jumping onto the demo, I'll quickly share you the plugin descriptor property. So it basically has some fields like name, description, and all this stuff, but the main field is this class name where we have defined the Pi masking plugin. Then we have also defined the OpenSearch version, which is 3.3 here, and the Java version, which is 21. So these are all the commands which you can use to build the plugin. You can use gradle WSML to build the plugin. Then you'll install the plugin using the install command, and then you can start the OpenSearch process. I'll quickly show you the demo. I already have started the process, so let me screen this sheet. Is it not working? Yeah, so here you can see my screen. So I'll quickly see if my cluster is up and running. Yeah, so it does says green. Let's see all the plugins we have. So we already had installed the Pi masking plugin. Next, let's see if we have any indices. So for now, we don't have any indices. So I'll quickly first create an ingest pipeline. So since this is an ingest plugin, so we first need to create the ingest pipeline for it to work. It says acknowledge as true. Now let's ingest some of the sample documents which I have here. So I'll be masking the message field, the user email field, and the details field. So for the first document, we have some message which has some Pi, and the user field which has email and phone number, the details with some card entry. Let's ingest some more documents. Here we have the message, the customer info field which should not get masked as per our configuration. The last document here doesn't contain any Pi, so it should be same. So let's quickly hit the search. Now, as you can see, all the relevant personally identifiable information got masked. So in the details field, the card number got masked, the message field or the email and the SSN got masked. And for the next document, it has also masked the message field. And the last document is completely unchanged. Just a second. So, okay, yeah. So these were all the commands which I used. Okay, so this Pi masking plugin was just one of the many applications you can use with plugins. So you can check out previous session from yesterday where Ocean and Lucian, they showcased a few more examples of plugins and their applications. I think their session name was OpenSearch, a practical guide to building custom plugins. You can check that out. This will give you much more details on various other plugins and how you can use them. With this, we conclude our session. Thank you all.